Hi, everyone. Welcome to the second TezTalks episode of 2022. My name is Marissa True. I'm joined, as always, by my co-host, Stu Elms.
Hi, everybody.
So, on today's episode of TezTalks Radio, we're going to take a deep dive into the ongoing evolution of the Tezos blockchain. And for that, we've invited none other than the founder and lead developer of Marigold, Gabriel Alfour. So, welcome, Gabriel.
Hi, everyone.
So, to kick off this discussion, and before we really get into things, I'd like to ask you if you can share what Marigold is and what its mission is in the Tezos ecosystem.
Sure. Basically, Marigold is a core team. So by core team, we mean that it works on core development. So this is the corest or the lowest level part of the infrastructure. Here, when we say core development, we're talking about two things. The first thing is the Tezos protocol itself. So the thing that everything else relies on. And the core mission of Marigold, mostly layer 2 systems. So layer 2 systems are systems that are built on top of the protocol and that have as goal to scale the Tezos blockchain to many more TPS, basically. At Marigold specifically, we're working on two kinds of layer 2 systems. The first one is rollups, more specifically optimistic rollups, and the second one is sidechains.
Okay, so from what you're saying, Marigold has a direct hand in not just the evolution of the chain, but its core building blocks. But one question that I think everyone's always curious to know is what it is about Tezos that attracted you to this specific blockchain in the first place.
Many things. I mean, the two obvious ones, the two main ones. The first one is that it has been a proof of stake blockchain for a long time. And this lets you get away with a lot of complexities and problems that you get with proof of work. Not even talking about its environmental issues and things like this, purely on a technical level. And the second one is the fact that Tezos is a self-amending blockchain. I mean, obviously, if you want to work on blockchain protocols, it's quite important to have the possibility of actually merging your changes. So yeah, in that sense, Tezos was like, I think the first big blockchain to do that, and so it was natural to go work there.
So then, speaking of self-amending, Tezos is now on its 9th upgrade. So we're looking at Ithaca, and that recently went back to the proposal stage. And so before we dig into why it fell short of the necessary votes, can you share what some of the key features of Ithaca are?
Sure. I think the main feature, and it's actually the main feature because we've avoided doing multiple too big changes at the same time, is TenderBake. So TenderBake, as is in the name, is a consensus algorithm inspired by Tendermint. Because of this, you have a lot of benefits. The main one being much faster 1 or 2 block finality. So it means that you don't have to wait for confirmations and have probabilistic, how do you call this, finality, where blocks could be rolled back, as sometimes happens, and so on and so forth. Here you have the guarantee very quickly that everything is actually done. It's actually how to put it, a bit more optimized, just doing the maintenance of the consensus and so on and so forth is cheaper, which gives you more space to do regular operations, and which also lets you reduce the size of the baking rolls, baking bonds. But yeah, overall, it's a much better consensus algorithm. It's been in the work for a long time. We finally managed to get it merged, and that's quite epic. I think it's possibly the biggest change that ever was on Tezos.
Oh, wow. But there's obviously like a lot of fairly technical terminology in what you've just explained and floating around the conversation in general. For those tuning in who might not necessarily be blockchain natives, I was wondering if you could explain a couple of the terms we've been seeing a lot of in the space recently. The first one being liquidity baking.
Sure. Liquidity baking is not new to Ithaca, but sure. So before we start with liquidity baking, we have to start with two different stuff. The first one is the liquidity part of liquidity baking, and the other one is the baking part of liquidity baking. I think we can start with the baking part because that's the most straightforward one. In Tezos, we have inflation funding. It's not specific to Tezos. Most blockchains have inflation funding, and in Tezos we use it to pay bakers. It's a bit more subtle than this, actually. It's more like we use it to pay delegators. It's just that for performance reasons, we can have everyone have to delegate, also for convenience reasons. So delegators go through bakers to delegate their stake and so on and so forth. But yeah, basically the principle is simple enough. You create a new amount of currency every year, and you give part of this amount to bakers. You could also give part of this amount to other things, which is part of Tezos white paper, for instance. If you read Tezos white paper, there is a mention of inflation funding for marketing purposes. And the marketing that was envisioned is a quite nice one. It was like making a gift to a different charity every week of like $100K. Now that blockchain, grew much bigger, those amounts, seem to be quite small. But back then it was a really new idea, really fun idea, and so on and so forth. But so the idea of using inflation to fund stuff has always been there. In Bitcoin, you use inflation to fund miners, to fund other stuff. It has already been part of the Tezos white paper. So here the idea is just to use the inflation to fund new things, which is the baking part of liquidity baking. Usually that part is the easier one to understand. Now the other part that is more complicated because it is more technical is the liquidity part. So before we move to liquidity baking, we have to explain what liquidity actually is. And liquidity is an intrinsically technical term. So there is always the question of if I want to do, pop science, or if I just want to give the insights behind this. I think I'm more of doing the higher level, giving the insights rather than doing pop science. So that's what I'll do. Let's say you have a DeFi system that lets you trade between two tokens, A and B.
Okay.
People can bring tokens A and B to help with the liquidity of this automatic trader. By this, what we mean is that let's say there are only 10 token A and 10 token B. If we do any kind of automatic trade, we can see that the trading rate will change very quickly. Because let's say I ask for 9 tokens A, there will be only 1 token A left. So regardless of the system and so on and so forth, we can expect that the price of this last token will be super high. So it means that by just buying 9 tokens, I will have changed the price to something nearly infinite, so that the last token can never be bought. However, if we imagine that there is more like 100,000 token A and 100,000 token B, for instance, we can imagine that I will need to buy much more before changing the price in any significant manner. And this is basically what liquidity is. So that's actually literally it. Now the more the more technical stuff that we can discuss later is why does this matter that much? Why do we want price slippage to be as low as possible? How does this work with multiple pairs and things like this? But the basic idea is that you want price changes as a reaction of short-term buys and sells to be as low as possible. And so what we do with liquidity baking is that we use part of the inflation to add more liquidity to a given pair. And the goal is that by adding more liquidity to this given pair, people will also have an incentive themselves to add more liquidity. So that's why it's also been called, liquidity subsidy, because it subsidizes bringing liquidity. The goal of liquidity baking is not to replace the entire liquidity, it's just to be an additional incentive for people to bring liquidity.
That's an excellent explanation. The next one I was hoping you could explain is blockchain finality.
Oh, yeah. So the main problem of blockchain finality is that it means different stuff in different blockchains, actually.
Okay.
You have different kinds of consensus, and depending on your kind of consensus, finality will mean something different. So usually we speak of Tendermint-like and Nakamoto-like consensus. So Nakamoto-like consensus is what you have in Bitcoin. It's what I think we still have in Tezos. Fundamentally, you have competing chains that have a different score, and there is a rule that lets you, score each chain, and the canonical chain is the chain with the, biggest score. And the thing that happens in Nakamoto consensus is that it's actually possible for the chain with the biggest score to be overtaken by another chain that has its last blocks to be different. So in practice, what it means is that, let's say I'm on a chain where the last blocks are A, B, C, and it has the highest score. Well, it is still possible that someone comes up with a chain that is like A, D, E, for instance, and that these blocks are such that they have a higher score than my ABC. So the problem in Nakamoto-like consensus is that you're never sure that your chain can't be overtaken by another one. So that's why we usually call it something like probabilistic consensus or whatever. So to go over this problem of never being sure that your chain cannot be overtaken by another one, we use what is called confirmations. So confirmations is just waiting for a set number of blocks, or like, well, historically, it never happened that your chain got overtaken, in a chain that was more than 6 blocks than it in the past. So I'll say that my criterion to be clear, to be absolutely sure that there won't be a rollback is I wait for 6 blocks. So the problem with this is that, well, it's probabilistic. You can still be wrong. So that's one problem.
Just because it hasn't happened before doesn't mean that it's impossible.
Yeah, exactly. There is a first time to literally everything. So if you want to be super sure, you'll need to be extremely conservative, and it means that your finality will be much longer. You will need to wait much longer. And so this is how Nakamoto-like consensus is. On the other hand, you have Tendermint-like consensus. And so in Tendermint-like consensus, basically, when like 2/3 of the nodes agree on a block, it's final, and that's about it.
Okay.
It sounds much simpler because it is much simpler.
So it speeds up the process.
Yeah. But as you see, it not only speeds it up, it also makes it much simpler. Okay. For instance, if you go on Ethereum and Bitcoin, or even Tezos right now, when you build a dApp or when you use a dApp, at some point you get the question of how many blocks do you want to wait. This is a very weird question. Imagine as a user, you're using a cloud application, a cloud native application. At some point you get the question, how many blocks do you want to wait? That's not the kind of stuff that make the user experience seamless. Whereas
so it's like you're choosing between security and speed.
Yeah. So that's if you understand what it is. So when you don't understand, it's just weird. When you understand what it is, it's worse. It doesn't sound good. Okay, I guess I'm training off security. That's not the kind of mood you want to put the user in. So instead, with Tendermint, it's much simpler. The user doesn't even have to think about anything. It's faster, it's simpler. The main problem of Tendermint is, like, if you take Nakamoto-like consensus, let's say tomorrow 1/3 of the stake loses their keys. Well, it can still go on. Whereas with Tendermint, if you have like half of your network that is down tomorrow, well, the network is slowed down and stopped temporarily. So that's the main trade-off. TenderBake is much simpler, it's much faster, it's also more optimized, but the problem is if you have like half of the stake that gets killed tomorrow, the chain is halted. It's not permanently halted, there are escape hatches, there are things that can be done, and so on and so forth, but that's the case that you trade off against Nakamoto-like consensus.
I see.
Basically. And
when I say very succinctly put.
Absolutely.
Yeah, no, I think it was very worthwhile to have that sort of explanation, especially as this technology obviously evolves. There's going to be less and less involvement of the daily active user in the direct handling of security measures and having to know or even understand how many blocks should pass before blockchain finality is reached. But then, when it comes to those who are very well versed in the infrastructure of this technology, can you go into a bit more detail as to why Ithaca has been met with this contention? Why did it have to revert back to the proposal stage? And I know, for example, one aspect of it was the notion of liquidity baking. And what other aspects did people have issues with?
So the thing is, I mostly work on the technology. So I actually don't follow social media that much. I follow some specific projects, that I'm interested in, and so on and so forth. I don't follow, chatter and this kind of stuff. So it's mostly people who come to tell me, like, there are people speaking about this, blah, blah, blah. We now also have a social media person at Marigold who's mostly writing blog posts and things like this, but also, follows what happens. And so he tells me whenever there is a lot of issues. As far as I can see, it was a combination of two things. The first one was the kerfuffle with liquidity baking, and the second one, which is incidental, is big bakers. Well, two big bakers, if I recall correctly, voting no, but near the end, so there wasn't enough time for other bakers to vote yes, so that it still passes. But yeah, I think that's it. But yeah, I'm not the best person. I'm not a social media kind of person. As you might have seen, I don't even like putting my picture out there. So yeah.
Well, as somebody who obviously dedicates a massive amount of time and effort to building out upgrades like this, do you find it discouraging at all to see something like this happen?
I don't even think in those terms. The thing is, when you work on core tech, you have a much longer term view of things. So from a point of view, it's mostly a setback of like 3 months tops. I know that people want TenderBake, people want this kind of stuff. With liquidity baking, as far as I can see, it's not even that people don't want liquidity baking as much as some specific people move the goalpost to, instead of liquidity baking, governance and so on and so forth. I think, it's all well and good, but when you're actually working on stuff, you don't have that much time to dedicate to such things. And when I say such things, it can be very social stuff, like following social media and things like this, but it can also be more concrete stuff, like this talk, where I explain various concepts and things like this. I mean, that one is easy enough. You ask me questions, I can answer, and if something is not clear, you can ask me additional questions. But by writing, it's actually very hard because you need to find people who understand, what is happening on the technical level, and who are good at writing, and who have time. So the thing to understand is that we are working on extremely technical stuff. So when you have someone that is good enough technically to work on the stuff, usually you want them to work on programming full time. And if by any chance they are also good at technical writing, you want them to work on internal documentation of the actual code base, not user-facing documentation. So if there was, an endless supply of technical writers that were highly skilled enough to understand the internals of Tezos, I will be like, sure, let's participate, and so on and so forth. Right now, we're mostly always under the water. So from a point of view, when people say, yeah, we should do more popularization and we should work more on governance and things like that, I'm like, sure, we'd love to, but this directly trades off against, implementing performance improvements, features, and things like this. And so that's a thing that we're solving. Marigold is growing, TriliTech is growing, we're working with Nomadic on this kind of stuff, and so on and so forth. Like, we're trying to address it, but it takes time. So from a point of view, it's not really discouraging. It's more like it will be
a problem that needs to be solved.
I think it's super interesting, because I think if there's any way we can all describe a blockchain community, whether it's Tezos or any other chain, it's that everyone is deeply, deeply passionate. And I think that's where a lot of the emotion and the criticisms often come from. They often come from good places, because everyone wants to see the chain thrive. But I completely agree with you that there's so much technical complexity here that unless you can translate these topics into a very straightforward, easy to understand language, a lot of it is going to get lost. But you actually just raised...
I would also say something else about this, which is another reason why I don't care much, about the setback and things like this, is that, as you said, most of it come from a good place. Expect most of the actors, to be in good faith. Most, it's always possible that some are not, but I expect most of the actors to be in good faith, even if they don't understand technical details, even if they don't understand how some stuff works and things like this. I expect most people to be in good faith and to want Tezos, to get better and things like this. So from a point of view, it will be done because people actually want what's best. So there might be a temporary setback where you have to, take time away from core development and explain more things and so on and so forth. But in the end, I don't expect, people to explicitly be to want to stall the good things that are coming to Tezos and the kind of stuff that we can only do as Tezos, basically.
So it's also possible that that's better for the health of the ecosystem and the community, for people to have a bit more of a grasp on what's going on behind the scenes, right?
Yeah. I mean, there's not a lot of behind there. Like, everything that happens, is open development. You can always go on GitLab.
I guess I just mean behind the scenes in the sense that they don't necessarily understand it.
Okay, if you mean in a technical matter, yes. But I mean, when you're working on open source software and all your development, even your issues and tracking of merge requests and things like this is done, on an open platform. Yeah.
Mm-hmm. Yeah, and I think it's kind of the principle of having and welcoming open and critical thought, whether it is eventually useful or not. You still have to have it there, because it may, at certain points in time, offer you a different perspective that you may not have considered before. And so it's always this constructive process with the people who are, using the chain at the end of the day. But then when you do have this situation where an upgrade proposal has been brought back to the proposal stage after the vote, how do you seek resolution, especially as you cross collaborate with all of the different teams from Nomadic Labs, Oxhead, TriliTech?
There is no handbook of what to do after a proposal, was voted down or whatever. So it sounds like an overly general question. But let's say, the concrete case. We basically speak with each other. It's very common sense. We schedule meetings. We try to understand what was the problem. Here, the problem was mostly, that not literally every baker has participated. So a few bakers saying no was enough, for instance. Then we try to understand, what is in the know. And so you read the arguments online. You just have to come through social media. And the problem here is that it's not like there is a main canonical argument, against liquidity baking. For instance, if there was this big argument against inflation in general, and that everyone, that was against liquidity baking was like, oh yes, that's the reason why. Well, you could actually start to argue. The problem here is that you mostly have, what I've described as a Gishgallop, where you have like a mountain of weak, like a huge list of weak counter arguments. And that's not the kind of stuff that you can argue with. That's what I did, when I was a teenager on online forums. I would love doing that. I know the thrill, and I will make my own Gishgallops. I will make my own pile of bad counter arguments just because I wanted to argue for something. So, if you've been, as online as I was, you've been there. But the thing is, yeah.
I was just going to say that I think it's interesting that essentially when you do take the time to look online and you do read through the counter arguments that criticize something that you've spent a lot of time technically putting together, how you provide a technological solution to a problem of principle. Because obviously, as we just explained, we can all go to war on the internet and we can all bicker and troll each other, but the solutions often never reach just because we're out there to just have the argument. But when it comes to finding a solution that everyone's happy with in terms of the actual integral technology, how do you switch that mindset to be like, this is a solution to that principle?
Yeah. So here it's straightforward enough. If you see, that the thesis doesn't have any strong argument, then you can go all Freud and be like, well, it's not about the thesis itself, it's about something else. And here, you don't have to do a lot of psychoanalysis to see what it is, because people actually wrote about it explicitly. Initially you had a lot of bad counterarguments that were then, replied to, and there was no response back because, well, that was about it. But you still see that people kept arguing. And so it shows that the counter arguments were not the real reason why they were doing this. And you see this with the goalpost having moved, between, I think it was 3 months ago and now. Now the question is not even about liquidity baking anymore. It's much more about governance and having options for bakers and things like this. And so here, the technical solution, there are two. The first one is to start engaging with bakers much earlier, so that you don't have bakers who feel safe in not voting, and then at the end, have to panic vote very quickly, and it usually doesn't pan out. So that's one part of it. And the other part of it is, how do you call this? Appease the people, who want more governance, even though, from my point of view, it's superficial, even though you're just making another proposal with the sunset not being bumped and so on and so forth is extremely superficial. At some point, if that's what people want, and, it doesn't cost that much to me, then, you compromise with other people, you're adults. You don't always do everything that you want. I think that's about it. Sometimes you disagree with other adults, even though you're correct or you're right, and that's okay.
Well, it's definitely interesting to see these things unfold in terms of coming to resolution on this stuff and finding ways to compromise. We're to a certain extent watching it happen in real time, right?
Yeah.
Now, bringing it back to Marigold in general for a second. When I was looking into Marigold leading up to the pod here, doing a little bit of research, it jumped out at me. You use very specific, particular types of language when like on your website and in the ways that you communicate about the company and what you're doing. Words like collaborative, flat, dynamic. Can you talk a little bit about how this reflects the Marigold philosophy in what you guys are doing?
So I think that's a really fun question. The reason why I think that's a really fun question is that I personally didn't spend much time on the website.
Okay.
And it was mostly people from the team and the social media person who
Great
I
marketing.
don't want their name, published like this, who worked on it. So, for instance, flat is an adjective that I wouldn't use by myself because that's literally not how I conceive of stuff. I also think that Marigold is not flat at all. From a point of view, there is me at the top, then there are the managers and tech lead, and then there are the employees. But paradoxically, the employees call it very flat. And by this, I think they simply mean that they have input on all decisions.
Well, they must feel empowered to view it that way, right?
Yeah. But from a point of view, that's quite normal. I'm very pro-duocracy, where people who do shit gets to decide shit. You code, you choose, and this kind of stuff. So I think that's mostly what they mean by flat. But no, there is an actual, structure, and people have to follow projects and so on and so forth. It's just that when they disagree, they can voice it. And if there is anything of substance, well, we integrate it, basically. It's okay to be wrong. And it's even better when your employees can tell you you're wrong. But I think that's mostly what they mean by flat. By collaborative, there are multiple things. The first thing is that there are multiple teams within Marigold, and they all collaborate with each other. And also collaboration with external teams. It can be, Lego that I already lead. It can be tool teams like ECAD or Baking Bed, or it can be other core teams like TriliTech and Nomadic. Something like, at the beginning of Marigold, a little bit more than 1 year ago, it was actually quite hard to communicate with Nomadic. There was, a big culture gap. Marigold was just being created. There were no actual processes and so on and so forth. But now, after a year, we're in a very good place. For instance, there are 2 workflows on rollups. One is mostly with Marigold, the other one is mostly with TriliTech. Both are with Nomadic, and both are working out really great. It's not really a Marigold or a Trili or a Nomadic project. It's just, a Tezos project in which you have multiple teams collaborate and contribute. And of course, whenever you have people from different teams, you have frictions and so on and so forth. But that's part of life, and most people, again, are in good faith. Something that is very important is that nearly everyone that is working on core team could make much more money in working on other stuff because they're good enough. So it means that if they work, in a core team on core stuff, they actually like it and they actually want to do good. So in this kind of context, even when there is friction, even when there are actual conflicts between two people from different teams and this kind of stuff, it always gets resolved, one way or the other. So it's quite a good environment. I think that's what was meant by collaborative. And I forgot what the last word was. You say there was flat, collaborative.
Dynamic.
Dynamic.
Oh, yes. So there are always 2 ways you can see things. The first one is dynamic is a good thing. You're reactive and so on and so forth. The second way is the bad way. Dynamic means shifting priorities. And so here it's both. In blockchain space, especially layer 2 consensus and things like this, the technology evolves, every 6 months. It's like working, on the latest web framework, except here there is no documentation. It's only research papers. So you have literally the worst of both worlds. You have the ever, changing, very quickly changing, fast-paced world of high-end technology and the complex world of theoretical research, and you have both of them. So you have to be dynamic. It's not literal. It's not really an intrinsic quality. It's more like if you're not dynamic here, you're dead.
Yeah.
Yeah. So I mean, we essentially covered that there's a united commitment to Tezos across all the core dev teams, as well as enough of a system of checks and balances and friction points that kind of keep everyone aspiring towards the progress of the chain, which obviously can only be a good thing. And that's the thing that hopefully will give Tezos its longevity well into the future. So then from that point, in terms of the advancement of Tezos as a technology, what has Marigold been working on in terms of building out layer 2 scaling applications, as you mentioned earlier, and LIGO? So what are some of the plans that are in the works for its further development?
So for Marigold, the main plans are optimistic rollups. There are two workflows that Marigold is working on for optimistic rollups. The first one is a protocol amendment that adds optimistic rollups just for transactions, like ticket transactions and possibly multisig. So it's mostly an initial version that will then be extended into smart contract rollups, so full-blown rollups, basically. So that's the first work stream. The other work stream on optimistic rollups is to do it in a smart contract. That was the initial plan, as is done on Ethereum, for instance. But back then, Mikkelsen was not efficient enough. But thanks to the work of many people, now Mikkelsen has basically everything that you need to do it. It's still much better to do it as a protocol amendment. You benefit from better code, from better performance, better integration. But the advantage of having a work stream that does it in a smart contracts is that, one, you de-risk the first work stream. Let's say the tech lead on the first project dies tomorrow in a car crash. You don't want the entire layer 2 effort, of Tezos to be halted just because of that. So it's good to have other work stream. You also have internal redundancy, obviously, but I'm talking, conceptually. And the other advantage of having it be in a smart contract is that you don't need to wait for a vote. You don't need to wait for an amendment. You don't need to wait for all of that. So it can be deployed much quicker, much more quickly. And also, if there is any issue, you just need to redeploy a contract. So it also lets you be more iterative in the approach. Whereas, when you do an amendment, you have to be extremely confident. You have to do a lot of reviews, a lot of tests and things like this before you can, even think to actually merge it. Whereas here, it's a smart contract. Worst case, you just redeploy it. So that's for optimistic rollups. The other one is sidechains. So we're working on Deku, which is our sidechain software. It's using TenderBake right now. There are two main workflows on sidechain. The first one is building a canonical Tezos sidechain. The idea is, let's say you care less about decentralization and more about speed and compute and so on and so forth for a specific application, while you can move to the canonical sidechain and interact with everyone else that has done so. So that's a basic sidechain workflow. And the other one is more enterprise. You have a lot of institutions, who want to come to Tezos, but don't necessarily want to start on a public blockchain, or mostly want interactions with Tezos, but don't want to do their main work on Tezos itself, and so on and so forth. And so for them, enterprise sidechain is like the right trade-off, specifically the right trade-off. I know it's not really popular, in fully non-permissioned blockchains and things like this, but I still think, it's a good, it's an important use case. Even if it's not your main use case, you still want to have it for institutions. It's also, a nice gateway before actually moving on the blockchain. You have a lot of projects that might be skittish about moving everything to a new technology, fully public and things like this. So being able to have things on the sidechain that you control, at least for 6 months to a year, is a nice trade-off. I know it's less interesting to most people, but from that point of view, I'm mostly trying to build a new infrastructure. And so I need to cover everything. And it will be very sad, that we have an epic blockchain, with epic layer 2, epic consensus, epic everything. And then institutions don't use it because they don't have this building block that they actually need. So that's the other workflow of the Deku sidechain thing. And this is mostly what we're working on at Marigold.
So it's essentially adding extra features and abilities and making it more accessible to general developers to almost encourage them to start building, their dApps or whatever projects they would like to on the blockchain, as well as making it more accessible for institutions who want to use it as a bit of a test bed, but don't necessarily have the confidence to go all in. And so
Yeah,
that's where this enterprise sidechain would have its appeal. And
yeah,
that's obviously like a necessary step towards this idea of mass adoption. Would you
exactly.
say
And
that's right?
sometimes it's not even as a test bed. Sometimes it's just, you want to be interconnectable or to have an easy connection with blockchain, but not necessarily be on the blockchain because it simply doesn't fit your use case. So you want an intermediary solution between, fully custodial cloud and fully decentralized blockchain. Not necessarily as a test bed. It can actually be your end goal, and that's okay. Like, not everyone wants complete decentralization. I can understand that.
Yeah.
So we're coming to the end of the interview here, but before we finish up, is there anything else you'd like to tell our viewers about Marigold or where they can learn more?
Well, I think we have something like 16 blog posts. It's just that we don't communicate too much, but yeah. We're writing more. Hopefully, by the end of Q1, we'll have a nice workflow where we can just communicate all of our updates in a nice format. So when I say in a nice format, I mean, consistent, every 2 weeks on social media with a nice page where people can ask questions and things like this. So I think this will already be, for me, a big win. Then on top of this, the main stuff that we're looking for, communication-wise, is technical writers or technical video makers. I mean, writing is nice and low energy, especially for devs. But in the end, a video is much more expressive, much more easy to understand. And so we're working on this. It's just that finding the right people is hard. But yeah,
Right.
please stay tuned and communicate much more in the coming months.
So if you are a writer or a videographer with a real knack for understanding highly complex technical material, then they should contact you. And
Yeah,
I think that call to action is probably one of the best ones we've had yet. But I think to everyone who's tuning in, this has been a real technical Tezos foundation layer one-on-one to understand some of the terminology, some of the key reasons why Tezos is built the way it's built and why it's designed the way it's designed, and also a little glimpse into how it's going to be shaping up in the future. So thank you so much, Gabriel, for sharing your perspective. I've learned a lot.
Pleasure.
I as well.
I'm almost a little bit impressed with myself that I managed to grasp some of these complex materials. And I'm sure the same goes for you.
Absolutely.
But yeah, thank you so much, Gabriel. It's been an absolute pleasure.
Cool. Thank you both. See you some other time then. Bye.
See you soon. Bye.